Welcome to the Scaling Tech Podcast, the podcast for software engineering leaders. I'm Aaron Syme, your host, and today we're going to talk about a really important architectural topic in modern software applications. Build versus buy has been a common question in software architecture for decades, but many cutting edge applications today incorporate an LLM or machine learning in some form, and that adds a new dynamic to the old question of build versus buy. Multiple high quality but expensive LLM APIs exist for different purposes. Should you use one of those SaaS based APIs or try to train a model of your own? My guest today, Jean-Louis, is an expert on this topic, and he had to answer these very questions when starting his own company for audio transcription services. So, this is going to be a very interesting conversation. So, take a quick moment to hit the like and subscribe buttons on whatever platform you're enjoying this episode, and then let's get to my interview with Jean-Louis.
Welcome to the Scaling Tech Podcast, where we help you manage your growing engineering team. Through expert interviews, we help you navigate the challenges of leading, hiring, growing, and nurturing your tech team to deliver the value your customers demand. Brought to you by agilityfeet.com, experts in staffing engineering teams in Latin America for clients globally.
Jean-Louis is a founder and CEO of Gladia.io, a company that builds audio infrastructure for automatic speech recognition. Their APIs provide asynchronous and live streaming capabilities for voice recognition in multiple languages. Over the course of his career, he's worked as a data engineer, a CTO, and with AI and quantum computing services. Based on this extensive experience, we'll tackle the question today about build versus buy for LLMs, so that you know what are the key considerations when architecting your LLM-based application. Welcome to the Scaling Tech Podcast, Jean-Louis.
Thanks for having me, Aaron.
It's a pleasure to speak with you today. I want to start with something that you recently wrote. You said that voice is the biggest challenge for AI. So I'd like to start with that. Why is voice the biggest challenge for AI?
Because thanks for asking the question. It's very simple. Nobody likes errors, and there's nothing that looks more like a summary of ChatGPT than a summary of Claude. Like they all kind of look the same, even if they are not using exactly the same words. They globally means the same thing. The problem you have with speech recognition is like nobody's gonna be tolerant with you if you make a mistake on the address, on the names, first name, last name, phone numbers, etc. So you need to be perfect, and perfection is extremely hard when it comes to AI. Especially if you want to have it extremely low latency. And that's something we're going to talk about with the latency part.
Yeah, absolutely. Yeah. So we have, most people's experience with Gen AI, with LLMs today is working with a text-based interface to a chatbot, right? To a chat GPT, for example. And so when we're dealing with text back and forth, there's a lot of forgiveness there that we don't have in audio. So yeah, a whole extra level of complexity there. So I'm sure that will factor into our discussion of should you build or buy when architecting an LLM-based application. But let's start first. I want you to tell us a little bit more about your work at Gladia and how you started the company, so we have a little context around your expertise in this space.
Sure. So I used to be an engineer, I'm still an engineer actually, but I used to be working in one of the biggest cloud provider in Europe, it's called VHCloud. It's actually the biggest one, even if it's small compared to the US market, but still a very interesting company. And back then we were seeing like most of the companies out there were having extremely hard time deploying AI internally, either for the business cases. They were having hard time to define what were the business case and the ROI, but also technically, because something is very special with AI is that you're using state-of-the-art computing power, like GPUs, for instance. And the problem with that, it's that people are not used to those kind of infrastructure and operations, and that makes your life a bit more hard than you would have with a traditional server. When a traditional server is failing, the CPU will die and the machine will not respond. Easy, you remove it and then you take a new one. If the disk failed, then you can't write to the disk, the system crashes, you move to another machine. And you have plenty of CPUs everywhere. And what I'm seeing and what I've seen in the past is that people were having extremely hard time monitoring the GPUs, which are just a tiny component on the machine. And when it's failing, it's not like yes or no failing. It can be failing and being idle and say, hey, I'm computing. And you're like, yeah, can you give me the results? And it tells you, yes, I can give you the results. Okay, show me the results. I will show you the results. And you keep like asking, and the system is like, I'm computing, I'm just computing. But in fact, it's dead behind the scene. So it's not that easy to monitor those infrastructure, and people are not used to do that. In general, we saw that it was hard for the business to define the ROI. The IT teams were like having a lot of troubles to deploy. So what we started, and when I started the company, was like, hey, I'm going to give this one tool when you have one size fit all, and you're going to have 500 APIs into one single container, and you will be able to deploy any AI in your company. And that was a good idea uh, on the paper. And the problem that you have when you do everything, you do nothing. You are lacking of focus, which is a traditional engineering problem. We think that more functionalities means that like the product is better. Actually, that's not true. I call it like being laser focused. Like you have a defined level of energy in your system, and if you have 500 APIs, means that you define one over 500 in terms of energy for each API, and that's not enough focus. So we decided to focus only on one of them, and to define which one of the 500 was the good one, we just spent our time talking to the business, all the VPs, the CXO that we knew. We just call them and say, hey, we have massive problem in the industry. You have massive problem in the industry, sorry, in general. What is the biggest one that you're having? And they tell you is, for instance, supply chain optimization. They tell you it's like finance forecast, etc., etc. And we just, every time we're talking to someone, we're taking the use case and putting a little bar on it, say +1 and another +1. And at the end, what we found is like the use case that was having the biggest impact in the company was the speech recognition. It was too slow, too expensive, not good in quality. And it was like the one with the most bars. So we just counting, talking to people and counting. And we end up like building this ASR system. And when we released it like a few months after, it just boom overnight. We had like 500,000 views on the tweet. We had this like 5,000 people that joined the platform overnight. So we are not like ready to scale. So everything was crashing, but at least there were some people on the platform. So that was the first sign that we were in the right direction.
Fantastic. Yeah. No, that's a great story, and certainly a classic problem of any of us as engineers. Our tendency is to want to build everything. Like you said, I was talking with someone recently who was joking about a company that they worked in where they had written, 3 or 4 different XML parsers in house. We're like, well, that's a solved problem, right? There's so you need to have a focus on what really sets you apart. You all found that through automatic speech recognition through ASR, it's an interesting challenge for sure. Dealing with live streaming of audio and speech recognition. We already talked about how important accuracy is in that. Low latency, you mentioned, also very important. So I'm sure there was a lot of interesting architectural choices that you had to make around that. What parts of your technology at Gladia did you build versus buy?
So we actually built a big part of the infrastructure and the architecture. But at the beginning, when we started, we didn't build the model per se.
Mhm.
We took an open source model and we adapted to make it comply with the use case we were having. So, as you can hear from my beautiful French accent, I'm French, and as a French person, I was like facing a lot of issues with audio, and our customers were having a lot of issues when you're in Europe. It's like most of the conversations are happening in English, but you have some kind of words that at the beginning of a meeting or beginning of a conversation is going to be in your native language, and then you're going to switch to English. That's called code switching. And the second problem we're having is like because of the accent that we have, most of the system were like completely like frozen. Like it was like completely crap in terms of. So a big part of the job was like to solve those two problems. We take the open source and we adapt the open source and we build what needs to be built to fit our use case. So that was like a big like adapt to the use case. That's what I would mention. We did buy everything that was infrastructure wise because that's not our job. Everything that was not part of the job. I'm gonna give you another example. Billing. My engineers were like, "Hey, we can build our own Stripe integration within the platform." I say, guys, I know, but you're smart. And if I need to take your smart brain for something, it is to solve my own problem, right? Which is my business problem. So
Right.
everything that was about billing, invoicing was not done internally. We just bought from a provider. It's actually called Hyperlane.
Hmm.
The other things like authentication. Yes, we could build our own authentication and etc. I don't want you to spend time on that. I want you to
Right.
spend time on the real problem we have to solve. So all the questions were like, how much time we're going to spend? What is the um, um, ROI we're going to have? And what's differentiator we are bringing to the market by doing everything internally?
Yeah.
And most of the thing was like focus on the problem and
Right.
don't focus on the things that are already been solved by the industry and just pay for it and get the go to market motion that you need.
Yeah, exactly. Especially in the scenario like you were describing, where you had very strong early interest in using the application to the point where you're having problems with that initial scale, right? You don't want to spend time, refining billing and invoicing systems. Instead, working on, helping it to understand a French accent on English better, right? That sort of thing, as you said. So yeah, one of the major like cost considerations as well as architectural considerations when using an LLM is which model to use. So how did you? You said you started with an open source model, I believe. So how did you decide if you needed like the latest version of a model or an older, cheaper model that you could use? How did you do that sort of evaluation?
That's a very good question. It actually all goes back to what is your end goal,
Mhm.
right? Sometimes you want to go fast, you want to be real time, then you will need a certain type of models. Do you accept approximations, hallucinations, or not?
Mhm.
On the other end, you can ask your questions if it's real time, which type of environment you're running on, right? So if you think about like ASR and architecture, but it could be for LLMs, kind of the same questions, like which language you're going to cover,
Mhm.
which are you going to have a system that's going to be accent sensitive or not accent sensitive? Are you going to be having a system that's going to run with background noise or not? Are you going to have accepting the biases that's going to be in there? I'm going to give you examples. Female are recognized like 20% less in accuracy than male, just because the data sets are based on male that are overrepresented over internet and people train on internet.
Yeah.
Are you going to have a bias that towards US because US is like feeding the internet, so it would be like less UK
Mhm.
oriented in terms
Right.
of grammar than US oriented? And I'm just talking about English, just matching other languages.
Right.
I can talk about the format you're gonna have, the type of file you're gonna have. So if you think, and what I'm saying is like ASR, but not only ASR. If you think about ASR, like you have some certain norms of encoding of audio in Europe that might not be the same in the US,
Mhm.
but it could be the same for OCR, for instance. If you think about like image recognition and OCR, um, we have A4 type of file formats, like the size of the sheets, and you have letter
Mhm.
formats that are not
Right.
exactly the same. It's going to have a bias in your system, right?
Right.
The colors you're going to have is going to have a bias. If you think about medical space and X-ray, most of the system are trained where the money is, which means in the US. You don't have the same pathologies as European or Asiatic people.
Right.
So you come to a fact where your system and you have these build versus buy questions and all these things. It's like which angle are you trying to solve? If
Yeah.
you're telling me like you want to handle a podcast situation and you want to have real-time transcription for podcast, people will have a nice mic like I have.
Mhm.
You have a nice mic. We don't have echo. We don't have reverb. We don't have any child crying behind the scene, etc. Is it the same system you're gonna buy if you're like running 911 emergency services
Right.
where you have like everyone shouting and screaming and noise around sirens in the background, etc. It can't be the same systems.
Yeah.
And maybe one is more fitted for the real time of podcast and the other one is more fitted to another use case. It's the same for LLMs. Looking for speed, looking for reasoning, looking for multilingual, looking for Hindi. Just an example, Hindi,
Yeah.
pretty bad coverage in language.
Yeah.
It's consumed 4 times more tokens than if you in Hindi than in English, right?
Mm.
So the cost of infrastructure, because it's been trained on English, the tokens that it was trained on, it's a bit technical, but like the sub part of word that it's been trained on was
Yeah.
mainly English. So if you want to represent the same concept in English and in Hindi, it's going to cost you 4 times more tokens on the Hindi language than in the English one. So you're going to have a cost at
Interesting.
compute. You're
Yeah.
going to have a cost on the time it's going to take. because you have 4 times more token to represent the same ID, it means like it has to generate those tokens. Yes, you have the time of compute, but you're going to have a problem of latency.
Mhm.
Which model you're going to choose?
Right.
So it's always about those kind of questions that you need, which is what is your end goal? What is your use case? What are the conditions the system is running? What quality you are able to accept? Define what is acceptable as a metric, and then you're going to be able to choose your model.
No, that's very interesting. You pointed out a lot of interesting considerations there. Obviously, cost is what maybe our business leaders, our business units are always most interested in, and our users of our applications are very interested in that. But you pointed out a couple of things I wasn't aware of. I was definitely aware of, unfortunately, that you have like, gender bias in training data, as you mentioned, that male speakers are recognized more easily than female because of training data. I hadn't considered things like, like you gave the example of a document type, a letter versus, A4, or like if you're doing something around legal documentation, then things like that matter, right? Or European versus US. And I definitely was not aware. So it's really interesting. It's something like in India that there's a higher use of tokens. So not only is it a matter of finding a model that understands the accents of your, the user base of your application, but that if it's the wrong model, it may triple, quadruple your cost essentially if it's doing 3 or 4 times the tokens in order to understand that. That's really interesting to me as well. So yeah, lots of considerations. I imagine then that, does this just come down to experimenting with them a lot? I mean, do you experiment with like multiple models in production or?
Yeah, exactly. So I think at this stage, it's a bit like search. I would say 25 years ago,
Mhm.
when you had Yahoo on the one hand,
Mhm.
you had Google on the other hand, you had plenty of other providers, and everyone was like trying to find who was the winner. And every week you had this new algorithm that was updated. DeepSeek like moment when you say,
Right.
"Oh crap, Yahoo did an update. It's perfect. Like it's better than." And then you see Google has an update, and then everyone switched to Google. And we had this kind of moments. We had this kind of moments when everything is kind of moving apart. There is no clear winner right now. Like Gemini
Mhm.
was crap a year ago. Like let's
Mhm.
be honest, Google failed miserably. Like they have the most brilliant people, but in terms of product, they completely mess up the way they were delivering this to the market. Gemini 1.5 was super good. Gemini 2.0 is insane. So what we are seeing is like every day things are moving apart. Mistral Large was like crazy. Now Mistral Large is a bit behind, but you have Quen that went up, and then you have DeepSeek, and you have all these things moving. So I think it's hard to say now that you have a proper methodology. I think the only thing is like test, try, look at the leaderboards. Face has an amazing LLM leaderboards that try to make these metrics that give a sense of what is good quality.
Mhm.
But I think in the end, it's all, and they're most of the time English, let's be honest. Most of the time it comes to like be in the real world situation, try XYZ and see how people are using it. So
Mhm.
I can give you plenty of examples. I'm saying that when I'm giving conferences in general, like about build versus buy and how to choose. And I'm going to go back to ASR because I still believe like ASR is a bit harder. But what I'm saying, like when the people are actually experimenting, even experimenting is full of biases.
Mhm.
Most of the programmers are male.
Right.
Like it or not, that's the truth. Most of the programmers are male. If you look at the statistics on GitHub, Reddit, and all these things, mostly male. Mostly into their 30s to their 45, 50. Okay, right. Most of them based in US. So the tone of your voice or the level of frequency that you're gonna have is definitely not the same one as your customers.
Mhm.
And I have an example of a company in France that was like starting to deploy their speech recognition for, medical in the medical space for medical appointments.
Mhm.
And I was like, "What you gonna do? You're gonna test in your basement at night with no noise behind as a male in your 30s, and you're gonna test the model with no accents because you're French native.
Right.
Who are the people calling you? Female in their 60s, 70s, looking for an appointment on Monday morning with probably kids crying in the background.
Uh-huh. Yeah.
Are you the right person to experiment and to test?" And so that's a good question that we need to ask, because engineers, even if you're testing, etc., it doesn't most of the time represent real life. And I have other biases that are super interesting. And it's the same. Build versus buy is going to be the same problem.
Mhm.
You're going to try an LLM and you're going to say, oh, I love this LLM. You try it at night on Friday. It's fast. Like everyone yesterday was like, oh, DeepSeek is insane. You know what's
Yeah.
happening this morning? They can't answer. The system is not able to answer because they don't have capacity. I'm going to give you another one, Claude. Amazing. And you have different type of reply. You can say reply concise, formal, etc. Every time I put formal, what it's going to say? It's saying switching to concise because of traffic.
Mm,
And that's another thing. On Friday, it's not saying that because nobody's there.
right.
On Monday, when it's busy, it's gonna change. The model is gonna change. People are sometimes even changing on the fly, gonna give you like more quantized model when it's high traffic.
Yeah.
So what I mean, you think, okay, maybe I should experiment in real life conditions. And sometimes you're gonna say, hey, if I want to have full control, maybe I should deploy internally. But if you deploy internally, you're gonna have the same problem. You say, hey, Monday morning, I have high traffic, I need to scale for high traffic. Perfect. So what you're gonna do? You're gonna host by yourself? Yeah, I'm gonna do on AWS, GCP, whatever. You know what? Everyone at 8 a.m. on Monday morning want to have GPUs. So if you want to have GPUs, you need to get them at 5 a.m., which
Right.
is eating your cost. And at the end, you go back to your ROI calculation. You're like, oh crap, I'm having the same problems that my provider are having. And if you want to have a forecast that is handling the case that I want for my customers, then I'm getting into a problem when I need to solve issues that are hosting provider issue that are not like business issues that I need to solve for my customers. So yes, you can experiment, etc., but there are so many parameters that needs to get into your experiment, so many things that can go wrong. So either you do it internally and or you do it externally and you focus on what matters, like the quality of your customer, etc. So it's always finding the right balance. There is no right or wrong answer, but what I mean is like be careful when you do it. You have biases. We all have biases.
Yeah, biases and how we train the data. And I think it's a really interesting point you bring up too, and biases in terms of how we test the application, the conditions we tested it in, who's doing that testing, all very relevant to how we will perceive the quality as developers versus how maybe our end users perceive it. And yeah, another interesting point you're bringing up to me there is, in my mind, that the importance of having a good application layer that can abstract this out, right? Like if somebody comes to Gladia for automatic speech recognition, there's a very specific purpose that they're coming to you for. They don't necessarily care how you're doing it behind the scenes, or even if you switched things out behind the scenes, right? They're coming to you for that very specific service. So you can have an application that, is set up to maybe use Claude on AWS, to maybe use OpenAI, to maybe use DeepSeek, right? To build something with DeepSeek, right? To have a locally hosted open source model. So having the ability to test those things out, maybe, even in production.
You have interesting things like what I always say to my customers, and that's something in general, even if you do it internally, like if you deploy internally or whatever. AI is I've been doing cloud for like, I shouldn't say my age, but like more than 15 years, okay? And for more than 15 years, I've never seen Google failing any call on API, right? Google is like, they are the best in reliability, right? They serve billions and billions of requests every day. It never fails. The only time I've seen Google failing is serving AI. So what I mean, like serving AI is very, very, very hard. And every time you bet on something, even internally, so you should consider yourself as a provider. You should have the same type of metrics. So I have a framework for that, but without going into too much detail, you should consider yourself as a provider. You should always have a fallback. That is the number one rule. You rely on ChatGPT, happy for you. Who's the fallback? Is it Gemini? So you need to test Gemini because Gemini is going to have other biases. Every regular expression, every guardrail you're going to put for OpenAI, you need to test it for your fallback because they don't reply the same way. And then you need to have another fallback. Maybe it's DeepSeek on Together AI. Maybe it's Mistral. I don't care, but I know like you need to have a waterfall of failing strategy because you can have rate limits. That's another big topic. Rate limits is a big, big problem. I've seen yesterday on LinkedIn, it was funny. People were like, oh, this sick is insane. It's cheaper and it doesn't have rate limit. Yeah, I checked this morning. It was like completely off. The system was completely off because they didn't have rate limit. We didn't have rate limit at the beginning. We all put rate limit at some point. Okay, there is no free lunch. So you need to handle rate limits, you need to handle guardrails, and you need to do that for all the fallbacks. So the question is, even if you do it internally, you need to have external fallback. That's the number one rule in AI because it's like it's a mess in hosting, even for us.
And all of this is changing so fast, so that sounds like twice or three times as much the work. In a way, it is to have multiple LLMs that you're working with to have these fallbacks, but it's necessary if you need a uptime in your production systems that's higher potentially than whatever. Let's say a fad of which LLM we're going to use, right?
I want to take a moment to tell you about our sponsor, WebRTC Ventures. At WebRTC Ventures, our teams are experts in building live video into your web or mobile applications. We've literally built hundreds of them. We have over a decade of experience using both open source and commercial media servers in a wide range of industries, including telehealth, edtech, broadcasting, and more. We also publish a lot of helpful tips and industry interviews on our website and our YouTube channel. So be sure to check out webrtc.ventures and we can help you build, scale, and deploy your video solution.
So I want to ask you a little bit about DeepSeek because, as we're recording this, I think people have only really been experimenting with DeepSeek for about a week now. By the time we publish this, it will have been a couple of weeks. And who knows what will have changed and what other insights we'll have then, right? And maybe there will be something else based on some of the same concepts, available soon too. So it's kind of a brand new LLM out there. A lot of hype and discussion about how revolutionary is it in the way that it has done its training or skipped parts of training, how it's hosted, geopolitical concerns with that one for sure. So there's a lot of pros and cons to consider. How do you think DeepSeek is changing the architectural landscape of building an LLM-based application?
I think there is a lot of noise, which is good for me because for me it's Black Friday on the market. It's time to buy Nvidia at a low price.
Right.
It's time to buy all these people at very low price. Like you get probably around a 15% to 20% discount today. So go for it. I'm not giving financial advice. I'm saying it's
Right. And by the time this is published, that will probably have passed. So yeah,
I hope
definitely
so.
not
I hope so.
financial advice. Yeah, but
But that's the Black Friday. That's how I see it.
right.
There is a lot of misconceptions. First, one of the things that shocked the people was the capability to have inner reasoning within the model, which is actually the first open source model to have the inner reasoning within the model. We've seen GPT-01 coming, I think it was a few months ago with this reasoning. In my opinion, it was kind of a fake one because it was more like chain of thoughts, which is a engineering artifact to orchestrate your LLMs, like asking the LLM multiple times hey, I have these questions. First, before you answer it, ask a question to the LLM. I have this question, how would you split it into multiple steps? And then you have these multiple steps in memory, and with engineering, you orchestrate the steps. And at each step, you ask the model, hey, try to solve part one. Try knowing that you have the overall problems, and I just solved part one, and the result is that. Can you solve part two? And that's why O1 was like freaking slow. What we've seen with DeepSeek was like the reasoning was within the model. It starts to generate tokens, which are think tokens. And it's kind of the training was like, I have some questions. I've been trained to generate a plan. And based on the plan, and the token is the plan, so I shouldn't consider it. It's kind of an extension of the prompt, if you will. Mm-hmm. And after, I'm going to give you the answer. So it's able to generate its own chain of thoughts kind of at the beginning.
Yeah.
And then is able to give the after the reasoning, is able to give the answer. So it's able to reason by itself without having artifact of engineering that's going to do it. Mm-hmm. So it's a smart way to do it. It's cheaper because you don't have to do multiple calls. It's faster because you don't have to do the orchestration and all the cascade of questions. That being said, it might be less precise. We still have to have some benchmarks that are pushing towards that. The other thing that kind of blew the mind of everyone was the cost of the training. And that's what crashed kind of the stock markets of NVIDIA, etc. And I looked at Intel, which has nothing to do. Like Intel is not doing training. It's like everyone was correcting everything. Like Microsoft has nothing to do with that. But NVIDIA, I would understand if NVIDIA would be corrected. But the fact is like nobody trusts like in the people that have a bit of knowledge, nobody trusts like the 5 million that were set.
Right.
So you have multiple hypotheses. The first one, I'm going to give you numbers. It's been trained on 2000 H800. So the capex, the capital expenditure for that is around 50 to 100 million. That was not included in the price, right?
Right.
Then you have the cost of operations, the OPEX. The cost of operations is probably running in China with, the stations they have, the power station, probably like 3 times cheaper than any US kilowatt hours that you
Right.
have. It's a bit like if I was giving you a ride in taxi,
Uh-huh.
and I was just only like giving you the price of the fuel without counting the price of the driver and counting the price
Right.
of buying the Tesla that is driving you, right? Or the car where I'm driving you.
Right.
So did you include the capex in it? Probably not. Maybe a big part of the cost is the capex,
Yeah.
right? So
Yeah.
and so maybe you're gonna say, hey, it's just electricity. Yeah, but when you go in the cloud, and I worked in the cloud for years, when you pay AWS, GCP, or whatever, you're paying for the electricity, but you're also paying for the reimbursements of the capex, right?
Mhm.
So you can't dissociate the two of it. So I don't know exactly how it was calculated. I know that just before the meeting we're having, like the podcast, I know they sent the corrections on the cost, and apparently, but I didn't have the time to check these things. But apparently, they said it might be only the pre-training.
Yeah.
So it might be only the base model, and all the magic behind DeepSeek was the reinforcement learning loop, which
Uh-huh.
made it reasoning.
Yeah.
So of course, if you exclude what the things that make it different, yes, it changes. The other question is like when you do training, you have multiple paths of training. Did you include those costs also?
Mhm.
So it's a bit unfair. We don't have numbers. We don't have the reality behind it.
Yeah.
But I wouldn't say that it's like completely transparent. So that's the
Yeah.
first thing. The second thing, and the third thing is the biases.
Mhm.
And I will handle with that. You know the biases. Ask any question about Taiwan.
Right.
Ask any question about Tiananmen. Ask any question about Xi Jinping or whatever.
Yeah.
You're gonna see what's gonna say. It's gonna have guardrails.
Yeah.
So again, might be a good model, might be a bad model, depends on your use case. So there are some suspicions also about the security.
Mhm.
Some people are saying that there are some backdoors and things like that. I don't know. I'm not an expert in security for those models, etc. But we know that Chinese state can be pretty aggressive in their strategy.
Yep.
And I'm not saying it's the case, but I wouldn't be surprised at some point that we see that this system is able to generate some code that will exfiltrate some data. And if you're not like particularly, I would say, looking into security and code generating, and you execute the code just because like it's reasoning, so generate those steps and build me an app automatically like everyone is trying to do, that is going to have something exfiltrating the data or doing some other stuff. So we don't know much. It's been 24 hours since we had the DeepSeek R1, but definitely I think there are some big news like always in AI, and then there is the reality that is happening a bit later.
Yeah, exactly. And for the context of our conversation, talking about a build versus buy, we're talking about people listening to this are people who are going to be deploying production applications to customers based on an LLM. Kind of even outside of the voice scenarios like your company deals with, but regardless whether it's voice or text based, accuracy is important, right? Hallucinations are a problem. Costs have to be actually managed and predictable. And all of these things, I think I guess as technologists, it can be fun and exciting for us to say, oh, there's a new model, let's go play with it, see what's different about it, right? But when we start to talk about we have to take this to production now and use it in a real world business scenario, we have to be much more practical and pragmatic and a little bit slower about doing it, right? And not just buy what is, part marketing hype and maybe part geopolitics involved of all the hidden costs that you mentioned, right? We can't assume that the way that DeepSeek is built is going to completely revolutionize costs and bring them down to 5% of current costs or something like that. On the other hand, there probably are some real technological improvements there that other models and other companies can learn from. And so, a perhaps safer route when you worry about the bias and the political concerns and the human rights concerns with China is being able to say, well, let's take some of those learnings and we'll see them applied in other models, no doubt. And it may not quite match the hype, but there will probably be something interesting coming out soon too that can be used without some of the same concerns. At least that's my initial impression.
You're right, and there are some artifact that you can make up. Like you think they actually gave numbers on the benchmarks, how good they were,
Mhm.
but the reality is like the model you're seeing in prod is a quantized model,
Yeah.
and what people don't realize when they do build versus buy and all these things is that when you're going to try to build internally or deploy internally, it's very likely that you're going to take a quantized model because you have cost constraints, you have latency constraints, etc. You're going to say, hey, I'm going to take this model and take the quantized version. So the quantized version, to make it simple, is like you kind of truncate the representation of numbers into smaller representation of numbers. Okay, so from 32 bytes to 16, 8, 4, 2, even 1 byte. Um, but what I mean is like the reality is like you don't know how the model behaves when you start to truncate all these things.
Right.
It's the same model, but is it robust enough to get the quantization and to be still relevant? So you would have this benchmark say, hey, we are the best. Are you the best in quantization? So giving you examples, a very big model from Mistral, for instance, a good, beautiful model from Mistral that might be, I don't know, 8 billion or whatever, you quantize it, might not react as good as a model that is called Phi, for instance, from Microsoft, 3.4, 3.5, for instance, Phi, that is lower in terms of accuracy in general, but reacts better to the quantization because it has been more compacted. So that's something that we've learned maybe even more from Phi, for instance, from Microsoft than from DeepSeek, is that what matters a lot in LLMs, if you want to go into production, so we are talking about production, both of us, I think that's what matters, right? Research is
Right.
great, but
Right.
production is like the real life. What's important when you want to compact your neural network and to have something that's going to be efficient when it's quantized and low resource, etc., is the number of tokens, so the size of the data set, compared to the size of the parameters. And it's better to have a big data set with a small model rather than having the same size of the data set with a high parameters. And it's pretty simple. It's a question of concentration of knowledge. So when you go into production and you start to cut those representation of numbers, of course, if you compact like a lot of data, you compress a lot of data, the system is going to be like more relevant. Even if you remove some information, you've seen so much that it's able to generalize enough. So again, DeepSeek, big numbers, etc. We don't know how it reacts. So about the build versus buy, be very careful. A model might have a brand, might have a name, might have a version. The quantize, which is what you're going to use and what your engineers will do, because going to find solutions. You're going to say, hey, that's the best one. We did a Mistral X 7 billion parameters. And say, we did, and it's in prod. What they didn't tell you is that it was not fitting in the GPUs, and they did the quantize one, and they checked the box. But that's crap in terms of user experience. So again, adding another bias around the DeepSeek and all this hype, we need to take into consideration the user experience. I mean, all the questions of this podcast, like user experience in the end.
It's true. It's true. That's incredibly important when we're talking about production applications. Tell us a little bit more about how you handled like training data with Gladia and with multiple languages. And did you do that not only around specific languages or accents, but like specific use cases or industries that you were targeting as well?
Yeah, that's a very good question. So it's a bit different from LLM again, but you have this question of how many hours do you have in the models. It's very fascinating. So I need to be very careful because we have a limited amount of time, but
Sure.
a bit like LLM. It's interesting to train on one language, but there are so many concepts that you can get from other languages that's going to be able to make you smarter in your own language. So for engineers that have been in those engineering schools, you did math, right? You did physics. The things that you learn in math are feeding you for physics, and the thing that you do in physics that are real world representation no makes sense in math. A vector is nothing in math. Like a vector is just numbers you don't realize. When you understand like the g-force is a vector,
Right.
oh, that's it. And when you see angles, doesn't make trigonometry, doesn't make any sense. And you say angles between vectors. But when you understand it's like an angle between forces and it implies a certain number on the physics and the physical world, then you start to better understand math.
Yeah.
And that's the same thing. When you train something in English, you learn some stuff. If you train something that has both French, Italian, but your goal is English, you're going to learn concept in other languages and representation of language that you won't have um, as robust if you only train on English. So that's a very interesting thing that you're going to have. And in voice, it's also the case because we have so many accents, so many ways. In US, male have very low voice and are speaking with very beautiful voice, like very deep. European are a bit different. Italian are speaking with hands and have different intonations. But everything that you learn, maybe we're going to learn better emotions if we have Italians, because they're going to exaggerate emotions. So when you go back to English, maybe you're going to be able to capture those more subtle emotions.
Right.
So that's a thing that is super interesting. The other thing that is a concept that is super, super important in every part of machine learning, deep learning, and AI, Gen AI, is called augmentation. That's the other key. The first one is like diversity and biases and stuff like that. And the second one is like, how do you augment the data? You should always think, how can I augment the data? Think about it as a bit like having money on an account, right? And how do I capitalize on the money? How do I make money $1 make being $5? And either you say I need $5, and you give me like you have to put $5 every time, $1 plus $1 plus $1, and it costs you a lot of in terms of training data. Or I can take $1, put that in the stock, and get $2, and take those $2 and get $4, and for $4 I can get $6. It's the same thing. I can take data and I can make it like better. So I'm gonna take audio, I'm gonna add background noise. I can add track with children crying in the background, right? It's the same
Sure.
data. It's me talking, right? I can reduce the sampling. For instance, like audio in your phone is 8 kilohertz. 8 kilohertz is what you have in the landlines. I can reduce that. I can add noise. I can add white noise. I can add reverb. You do podcasts, right? So in podcasts, you know how to change the reverb and those things. So you can play with that. That makes your data like 10 times bigger. And you don't have to pay for more. You just have more
Yeah.
robust systems. So in general, in Gen AI, it's like get the data being as robust as possible thanks to augmentation. You don't need to have like a lot of data. You need a lot of data in general, but you can make the data more interesting. So that's what I would say. And the last one, once you have a model that is generalist enough, then you can specialize. You can specialize it. So it's better to have a model that has 100 languages, like we have. We have our own model that is 100 languages. And then you're able to fine tune afterward this base model, a bit like the DeepSeek, right? You have this base model and then you fine tune it. Then you fine tune it on the language to be more specific, faster, better, but you have the concept overall. That's very interesting. And you can do the same with Chinese or Italian when you're going to take the base model and then specialize. And the reason you want to do that is if you have an overrepresentation of English, which is the case, you're lucky, you're English speakers, you're so lucky like to be in the US. But when you have an overrepresentation of a language, it's going to start to erase the other. It's going to be like really big, having a huge impact. So when you're like kind of fine tuning this big model that have a lot of concept and over a lot of languages, you're kind of removing the biases of English and increasing the footprint of this language that doesn't have that many hours, but with augmentation plus a bit more like focus on the language is able to give you like insane results. So that's the other key, and you can do that, apply that to LLM, you can apply that to image recognition, you can apply that to image generation, etc. It's always the same thing. General concept and then fine tuning. It's going to give you like insane results.
Fantastic. Yeah. And I like to the point about as part of testing and improving your model, doing things like adding in intentional background noise and making sure that it can still do good ASR from that and that sort of thing. All right. Well, this has been a fantastic conversation, Jean-Louis, and there's so many questions I wanted to ask you and we won't get to, but I do want to end with one that I think is a really hard one or a really important one for engineering managers who might be leading an LLM-based product. How do you define done in an AI driven application? Is there ever a point where you can call it done?
No, and there won't be. I shouldn't, because done means perfect, right? It means that you have 100% accuracy. And you don't want the system to be 100% accurate. because it's called overfitting.
Yeah.
So no, you don't want the system to be 100% perfect, especially with Gen AI, when you want to have a bit of
A
kind
little
of
bit of creativity.
craziness and creativity and stuff. So the question is like, what does mean? And I think that's probably it's happening at the end. So perfect. That's probably one of the big topic to address. Define the definition of done. Define what is good enough. Otherwise, it's going to be an endless spend of money, endless spend of engineering, endless spend of project management. Define what is good enough. Are you going to accept, as a US person and US call centers, that a person that is coming from, I don't know, the hand of the French, deep dive country, deep country of French, that is speaking like, in a language that is very specific from its region,
Mhm.
that is trying to speak English? Is it okay that the model is able to pick it up in English? Yes, it's okay. So define the scope, define what is good enough. Otherwise, it's endless spend of money, and you're never going to be happy, and you're never going to deliver the project. Especially as engineers, we have product managers on the other hand,
Right.
and we need to get along with the project managers that we love. But we need to define, hey, what's good enough for you, and where do you want this to stop?
Yeah.
And they should be answering the question, and that's their job, to call to the customers, talk to the business, talk to all these people to define the constraint. And you're going to feel this constraint, but that's a very big trap. I worked in anti-fraud for quite some times. You're never 100% an anti-fraud, right? It's
Yeah.
always finding like, are you excluding too many people or not enough, etc. So defining the balance, think about anti-fraud and the risk. It's all about risk taking. How much risk are you willing to take, and where do you stop?
No, that makes sense. So yeah, the team, the thing that your team needs to answer is not the definition of done, but the definition of good enough. So that's going to require collaboration between the engineers and the business, and then also the important takeaway for any business or financial leaders from this is that because it's not ever truly done, you're going to be constantly refining it. So you can't just use a project based accounting model that's going to assume that costs start to immediately go down after deployment or something like that, because you will still be continuing to refine that, working with the latest technologies behind it, trying out other models. So yeah, lots to consider there. Really exciting stuff, Jean-Louis. Thank you so much for taking the time to speak with me today about this. Are there any closing thoughts you want to share, or how can our listeners learn more about Gladia?
So thanks for having me. First, it was a pleasure to have me, despite my French accent. That some people in the US like.
I
Uh,
do.
nice. But people can follow me on LinkedIn and follow Gladia on LinkedIn. And on Twitter, I'm a bit active also on Twitter. And yeah, use Gladia. It's gonna help you in general in your life. Personally, I don't write emails anymore, to be honest. I have a shortcut to use Gladia on my Mac, and it's writing emails. I'm just like spelling my emails. And I think voice is gonna be back, and it's going to be the main way to communicate to the machines. I think like keyboards were an intermediate phase, but think about the whole humanity. We've been talking, continuing, and we tried to write, and we wrote what for? To keep traces of what we were saying, right? But now that you have AI that is keeping all these traces and is able to like to write some reports and write these notes, we don't need to write anymore, right?
Yeah.
So that's the big shift in humanity, in my opinion. Voice is the most compact form of knowledge. And I will finish with that. If you think about ChatGPT, ChatGPT is a podcast. You have someone that doesn't know anything about a sector or about a problem that asks an expert, and the expert is giving answers. And podcast is the highest form of intelligence and sharing in humanity. And LLMs are just replicating that. It's your personal podcasters. So I think voice is the key to humanity knowledge, and that's what makes us human and not machines, is because we have ideas and we're able to give the flow in a very compact way in a very short amount of time.
Fantastic. And I agree with you completely. Voice is the interface of the future. So, Jean-Louis, thank you so much for speaking with us today on the Scaling Tech Podcast.
Thank you so much for having me.
On behalf of the thousands of developers we've placed with our clients, I want to briefly tell you about our sponsor, Agility Feed. Agility Feed has been building nearshore agile teams for U.S. companies since 2010. We were an early pioneer in doing this sort of developer staffing. Our team can help you recruit talented software engineers and technical teams in Latin America. We'll handle all aspects of recruiting, contracting, and payments for you so you can focus on delivering great software. To learn more, check us out at agilityfeet.com. That's agilityfeat.com.